good morning all. In our class, we were discussing different works related to double integral. We were finding area using double integral, area of a region using double integral, then volume using double integral, and other works like find or evaluate double integrals. Okay. Now we have another section to discuss, which is to find center of gravity using double integrals. Center of gravity of a lamina using double integral. Okay, this is coming in section 14.8. Center of gravity using multiple integrals, or we are restricted to center of gravity using double integrals. Okay, so there are different formulas we want to know. First one is, what is mean by a lamina? Okay, so if you consider a region, this is usually called a region if you consider this as a geometric shape. Now if you consider a metal or material of this shape, then it is usually called a lamina. So that's an object. Region is not really an object, it's a geometric imagination, whereas lamina is a real object. Okay, it's a two-dimensional object. Okay, now if a lamina with continuous density is there, this lamina will be made of some material. Suppose density is given by delta of xy. Density is a function of x and y. At this point it will be having a density, whereas this point it will be having another density. So density is varying depending on values of x and y. Suppose delta of xy be the density of this lamina, then you can find mass of that lamina. To find mass of that lamina, mass is equal to double integral over r. R is the shape of that lamina. Double integral over r delta of xy dA. This is the formula to find mass of the lamina which having the shape of the region r. Okay, and density delta of xy. Then apart from lamina, we want to find center of gravity. Okay, center of gravity. In order to find center of gravity, we have a formula. Center of gravity is a point in this lamina. We want to find a point x bar y bar, which is a point in this lamina, which is the center of gravity. In order to find that one, we want to find both coordinates, x coordinate, which is x bar, and y coordinate. We want to find both. In order to find x coordinate, the formula is double integral over r x into delta of xy dA divided by double integral over r delta of xy dA. Now the denominator is actually the mass. So this is usually called my by m. My is momentum, first momentum about y-axis. My stands for first momentum about y-axis. Even it is my, the formula is x into delta of xy. If you are finding x bar, formula is x into delta of xy dA. Double integral of x into delta of xy dA. It is usually denoted as my by m. M is mass, my is momentum about y-axis. Okay. Similarly, in order to find y bar, the second coordinate of that center of mass, double integral over r y into delta of xy dA upon double integral over r delta of xy dA. Now this is mx upon m. M is mass, mx is momentum about x-axis. Okay, so this is the formula to find center of gravity, x bar y bar. X bar y bar is the center of gravity. Okay, this is the basic formula. Now we can do a problem. Find the center of gravity of the triangular lamina. Center of gravity of the triangular lamina with vertices at 0, 0, 0, 1 and 1, 0. Okay. So there is a triangular lamina with density delta of xy equal to x into y. Okay. So there is a triangular lamina with the density x into y. Then we want to find center of gravity of that lamina. Okay. So first we'll find mass, then mx, my, mx. So you can find using that formula we can find x bar. For that, in order to find mass, it is double integral over r delta of xy dA. Now what is this region R? It is a triangular region with the vertices 0, 0, 1, 0 and 0, 1. Okay. So 0, 0, 1, 0, 0, 1. It's a triangular region. Then mass will be double integral over r delta of xy dA. It is already written. Then what will be the limit? This can be considered as type 1 region as well as type 2 region. Okay, what is equation of this line? The line passing through 0, 1 and 1, 0. You can take 2-point form equation. You can see it is going through 1 in x-axis and 1 in y-axis. So it will be x plus y equal to 1. For those 2 points, x plus y is equal to 1. So that will be the equation of that line. If so, what is the limit for x and what is the limit for y? X varies from 0 to 1 and y varies from this line to this line. That is y equal to 0 to y equal to 1 minus x into y dy dx, right? Then which is integral 0 to 1 x into y square by 2 dx. Okay. Then this is integral 0 to 1 x into 1 minus 2x plus x square, 1 by 2 is taken outside, dx equal to integral of x will be x square by 2 minus 2x square will be 2x cube by 3 plus x raised to 4 by 4 0 to 1. Okay, which is equal to, you can take common divisor 12. Okay, 8 by 12 here, which is 6 by 12. This is 3 by 12. Okay, then it is 6 plus 9 minus 8, 1 by 12. So 1 by 24, right? So the mass of this lamina is mass equal to 1 by 24. Okay. After that, we want to find mx. Mx is my, double integral over r x into delta of xy dA, which is integral 0 to, the limits are same, integral 0 to 1 minus x square y dy dx. Okay, same kind of integral 0 to 1 x square into 1 minus x whole square by 2 dx. Integral 0 to 1, which is x square minus 1 by 2 into 1 this is minus 2x into x 2x cube plus x raised to 4 dx. Okay, now this integration you can do. The answer will be 1 by 60. Okay, from that x bar will be my by m is equal to, you can see it is 1 by 60 by 1 by 24 equal to 2 by 5, 2 upon 5. Similarly, mx equal to double integral over r y into delta of xy dA, which is also equal to 1 by 60, you can see. Okay, then y bar is equal to mx by m equal to 2 by 5 again. So x bar y bar, the center of gravity is 2 upon 5, 2 upon 5. This is the center of gravity. Okay, you can try similar questions. Then there is a special case. If the solid, if the lamina has constant density, if constant density, say delta of xy equal to k, then what will be the mass? Mass equal to double integral over r k into dA, which is equal to k into area of r. Okay, then my is equal to double integral over r x into k dA, which is equal to k into double integral over r x dA. So x bar will be equal to my by m will become double integral over r x dA upon area of r. Okay, this is also called center of mass instead of center of gravity, sorry, centroid. Instead of center of gravity, this is usually known as centroid. If the density is a constant, center of gravity is also termed as centroid. Centroid of the region R. So same formula of center of gravity, but if this x bar y bar, similarly you can find y bar as well. Okay, x bar is this one, then y bar will be mx by m equal to double integral over r y dA divided by area of r. This x bar y bar is called centroid. Centroid of the region. Okay, so same formula is enough, but you can simplify into this kind of formula, double integral over r x dA divided by area of r for x bar, and double integral over r y dA upon area of r for y bar. Okay, then you can see some questions. Let's try a question. Consider the lamina with density delta of xy equal to x plus 2y, then bounded by x-axis, the region, the lamina is bounded by x-axis, the line x equal to 1, then and the curve y equal to root x. Okay, then we want to find center of gravity of that lamina. So let's draw a rough figure of that region. Y equal to root x, then x equal to 1, then this x-axis. Okay, root x equal to 1 and x-axis, region in between the, okay, that is the lamina. Then mass equal to double integral over r x plus 2y dA, which is equal to integral 0 to 1 integral 0 to root x plus 2y dy dx. Then 0 to 1 x square by 2 plus 2y, sorry, x with respect to y we want to integrate by xy plus y square 0 to root x dx equal to integral 0 to 1 x raised to 3 by 2 plus then this is x dx equal to integral 0 to 1 2 by 5 into x raised to 5 by 2 plus x square by 2 0 to 1. Okay, this is 2 by 5 plus 1 by 2. So the integral is already done, plus 1 by 2, 9 by 10, right. Then my formula is double integral over r x into delta of xy dA equal to integral 0 to 1 integral 0 to root x square plus 2xy dy dx equal to 0 to 1 x cube by 3 plus, sorry, with respect to y we are integrating x square into y plus xy square 0 to root x dx equal to integral 0 to 1 x raised to 5 by 2 plus x cube, sorry, x square dx. Then it becomes 2 by 7 x raised to 7 by 2 plus x cube by 3 0 to 1 equal to 2 by 7 plus 1 by 3, which is 13 by 21, 6 plus 7. Yes. So x bar is equal to 13 by 21 upon previous mass was 9 by 10. Okay, you can modify this one, 13 by 21 into 10 by 9. You can try the cancellations. Okay, similarly for finding y bar we want mx, which is double integral over r y into x plus 2y dA equal to integral 0 to 1 integral 0 to root x yx integration will be with respect to y x into y square by 2 plus 2y y square 0 to root x dx integral 0 to 1, this integrations, then it is x cube by 2 sorry, x square by 2, x into y square by 2, where y is equal to root x plus x dx, x cube by 6 plus x square by 2, 0 to 1, equal to 1 by 6 plus 1 by 2 equal to 8 by 12, 4 by, 2 by 3. Okay, so corresponding y bar will be 2 by 3 upon 9 by 10 or 2 by 3 into 10 by 9. You can modify that. So you'll get x bar y bar as center of gravity. So this kind of problems you can expect. Additionally, centroid is a special case of center of gravity. Centroid finding questions also you can expect. Okay, so study this portion as well. This is also included for your examination. All the best for your exams. Okay, thank you.